All right. Hello, everybody. I am Matthew, and I am the leading officer for the reverse engineering portion of the Cybersecurity Club. And today I'm going to be walking you guys through a workshop on reverse engineering, or at least an intro to it. So we are going to be beginning with what is reverse engineering at its core. So at its core, reverse engineering is the analysis of an application to determine how it works. So that can be through dynamic analysis or static analysis, which I'll get into the difference between the two later. But the re-engineering of an application is also part of reverse engineering. So if you have an application that you want to figure out what it does, a good way to do that would be to start by re-engineering the process of the application. So you can kind of understand, like, through application, if you click a button, and you see the effect of what the button has on the screen, you can kind of understand like what it's doing behind it if you have enough information about like what it does. So that's also part of reverse engineering. You don't necessarily have to use some of these tools, but it would be useful to do so. So what can reverse engineering be used for? Well, specifically in cybersecurity, reverse engineering has been commonly used for figuring out what malware does. So like back in 2017, WannaCry, a famous ransomware, was like all over the internet. So these companies would be infiltrated by this malware, which would hold their systems hostage against them for money. And reverse engineering was actually used by I don't remember his name, but a cybersecurity researcher who figured out that there was a kill switch in the WannaCry system, which would basically just completely get rid of the effects of WannaCry on a computer. So that was done by reverse engineering the application, specifically the malware in itself, to figure out like, oh, there's a network request every 10 seconds to this web page, which is called kill switch. So they figured out that just by doing that, they can effectively kill the malware in its track. Then in Android in 2018, there was a malware called Agent Smith, which was a malware that basically attached itself to the Android ad library. So every time you would like open an app, if there were ads being displayed on one of these infected apps, your system was potentially at risk for Android because it was basically hijacking the entire ad system. And there's plenty of other cases that we could talk about, but that is a general gist of like what reverse engineering can be used for.
On the WannaCry, I remember watching a documentary on it. They because the link, like the activity sent something to a link, and that link wasn't registered. So like all they did was actually register the domain of that link.
Yeah.
And then stop it.
So that's basically what happened. They've discovered the link that was used as a kill switch. And then they also noticed that the link actually didn't exist. Mm-hmm. So they basically just kind of hijacked the malware's kill switch URL and registered it as their own domain and set the proper parameters on the domain for it to actually kill the malware. So that's part of reverse engineering. You find conditions that cause something to happen and you figure out a way to cause those conditions. Specifically in that instance, that's what they did. So, well, we know what it is now, but we also need to talk about how it was done, or how reverse engineering can be done in terms of processes. So we have static analysis. So the difference between static analysis and dynamic analysis, basically, if you're thinking about the word static, can anyone tell me what the word static means? No, that's completely fine. So static is essentially something just stays in place, right? It's not moving, it's not doing anything. We're just looking at it frozen. So what static analysis is we're taking the application, we're using tools to dissect it, but not necessarily using the program itself. The program isn't doing anything, it's just lying there while we take a look at it. If you want to look at that like as a medical analogy or something like that, it would be just like diagnosing a patient without actually doing anything to the patient. So we never run the application in static analysis, and we think out the behavior of the application by looking at its code, at least the code that is available to us as the reverse engineer. So if we know that a program does like a message box, we can see a message box popping up, and then with a few options, and it checks the option, and then it does something after that. We know that we can also replicate that. That's something that we can re-engineer. And then dynamic analysis is where we are doing something to the program. We are running the program, and the program is moving or doing something. Now, when we are reverse engineering, it is important to note that you never want to reverse engineer a program in dynamic analysis without a controlled environment. So this means don't run it on your computer. Use a virtual machine, because in the realm of cybersecurity, the odds are what you're going to be doing with reverse engineering is you're going to be reverse engineering malware or a virus, or some other program that you have no idea what it could do to your computer. So you don't want to just, oh, I'm going to download this and run it on my computer. No, you want to be sure of what the program is going to do to your computer. And if you're not sure, you want to run it on a virtual machine, because otherwise you're being pretty unsafe. So when you're doing this in a controlled environment, you can actually monitor what the application does and how it works, what it's doing on your system. So there's tools that like log what the application you are analyzing is calling in your system, or what it's accessing in your system. And you can monitor that with other tools to see like exactly what it's doing in your system. So this will give you an idea of like how the program is moving and all that, what it's calling in terms of operations. So there are a few things to know. You don't really have to stick to just one of these. You can do static analysis with dynamic analysis. In fact, most reverse engineers that are really successful in their fields, they are people that employ these techniques at the same time. They use these techniques to figure out how programs work, recreate them, see, and if they've recreated them successfully, they know they've successfully reverse engineered a program. So employing both of these techniques and mastering both of these would be really important if you're looking at getting into reverse engineering. And not just that, it also teaches you how to think more logically when it comes to programming. So if you're a programmer or a software engineer, reverse engineering can actually be really useful for you, because you can look at source codes of other programs and see exactly what it's doing there. So that's another part that's probably really important when it comes to reverse engineering. So we're actually going to start with some hands-on learning with reverse engineering. So this is going to be a section where I demo a reverse engineering tool called dnSpy. And dnSpy is basically a tool that we use for reverse engineering .NET applications. So if you've taken CS 111 here at Citrus, you'll know that, or I'd assume you'd know that .NET is C#, the language that you learn in CS 111, is a part of .NET. So this program that we use would be used for reverse engineering C# programs, VB.NET programs, and I believe that's all the .NET languages as of right now. So this tool would be useful in those instances, but not necessarily others. So if you would like to follow along, I'll give you a chance to follow with me as I download the dnSpy program from GitHub. And here we will go to the link. So the link for this is, I'm going to write it up on the board, but if you're following on the Zoom, you can see it in the search bar. It's going to be https github.com /dnSpy X. And you'll find the release for the program in the releases section right here. You'll see a version 6.3.0. This is the version we'll be using today. And if you click on that, we will go down slowly and we'll see that the release for the actual program is right here. Now we're going to want to download the Win32 version of the program. This is the version that we'll be using today for the reverse engineering, because in the workshop, the app that I have ready for us to reverse engineer is a 32-bit program. So I'm going to go here and I'm actually going to uninstall my version of dnSpy so that I can install it with you guys.
Is it the same one that was in the?
Yes.
Okay.
I'm having a problem with Wi-Fi. It's not connecting to her phone.
Are you using citrus?
Yeah, he's on Citrus.
And usually that was good all day.
Honestly, it's fine. It's not required that you follow along, but if you want to,
Yeah. That just happens in this building.
Is anyone here also downloading the program?
I have.
You have it. I'll give it about 2 minutes and then I'll continue. Let me see if there's any questions in the chat. Nope.
You don't only work for those over here. It only works out. Because why?
The blessed hands of touch the
Yeah.
computer.
Okay, so which one do you download?
It's going to be the dnSpy net win32.zip.
Oh, okay.
You say C# is probably one of the most common languages that you're disassembling.
It's what I started out with.
Okay.
If you're a reverse engineer, I would recommend starting out reversing .NET programs, because as you get lower and lower into what you're reverse engineering, like in terms of languages. So at the very top, we'd consider C# a very high level language. And it would probably be only under Python or something like that, because those are relatively really easy languages to understand what they're doing. But C# would probably be like right under that. And then all the way at the bottom, you'd have like assembly. And then above that, you'd have like C++ and a bit higher level languages.
Wait, so, okay, so you're saying anything that's .NET, they use C#?
So C# is a .NET language.
Okay.
So that's what C# is. VB.NET is also a .NET language. Now, what that means is C# and VB.NET, they're almost the same, except they aren't the same language. So they convert to the same thing, but they aren't the same language. So while VB.NET has a completely different syntax than C#, they both convert to the same thing. And I can actually show that when we demo it, but it'll be a bit hard to understand because it's a bit lower level, because what .NET is, it's really like a mini language. So C# converts to this mini language, which is then ran in assembly. So it's a bit complicated to understand that portion of it, but it's not really necessary for this demo today to really understand, but that's essentially how it works. Is everyone ready to continue?
Yeah, let me just go on console. I downloaded it, but just open up the console.
So you're in the zip right now. I'll actually show you. We're going to extract it.
Oh,
So I've downloaded it right here, and you're essentially just gonna want to put it wherever you desire on your desktop. So here I have like a entire folder specified for .NET languages and like my tools for that. So I'm gonna create a folder in this area that I want to put it in, and I'm gonna call it dnSpy. And just from there, I'm gonna extract all the files into that folder. And you don't necessarily have to organize everything like I do. I mean, I'm just really overboard with it because I have a ton of different tools for everything. But this is how I generally organize my stuff. I'll have like what language it's for, and then the type of tool for that language. And then the tool will go into there.
And the program that we're gonna reverse engineer down running.
Yeah, you don't have to run the program that we're reverse engineering today. It's not dangerous. It's just we're not running it. But I'll also send the program in the Zoom just in case you can't download it off of the slide, because I know Armando was having a bit of trouble with that. Okay, so all right, is everyone ready? All right, so we're gonna run our application. We have dnSpy installed now on our desktop. So if I go to run it, we will see our interface right here. And let me close this. So here is the standard dnSpy interface. So on our left, we have this thing called the Assembly Explorer. Now in Visual Studio, if you were in any of the CS classes, Visual Studio has a Solution Explorer. Now the Solution Explorer and Assembly Explorer, they're almost the same. However, instead of coding, we're exploring something. So that's where it kind of differs, because the Solution Explorer would be able to show us like the raw code and all of that. But our Assembly Explorer is going to show us all our assemblies that are related to the program we're reverse engineering. So let's see. We have our file tooltip right here on our screen. It's in the top left corner. And we have a few options from here, and we're only going to be using one of these options today, which is open. But there's a few other options that are useful, like export to project. Now, export to project, basically it just takes whatever program you're reverse engineering and actually exports it as a Visual Studio project. So you can actually just directly open it after that in Visual Studio and run the program in Visual Studio. So that's one of the cool features about dnSpy and what makes this a really powerful tool. So we're only going to be using one of these options though. So we're only going to be using open, and open does exactly what it sounds like it's going to do. We're going to open a file into our dnSpy Explorer. Now, before I actually do any of that, we actually have to download the program that we're reverse engineering today. So we are going to be reverse engineering the simple program that I made. It's just a simple text box with a button, and it expects a certain password. And we're going to figure out what that password is in this program. So that URL is the link to the download. It's a short URL, so it will take you to the download link. And if anyone has any problems downloading that, just let me know, and we're going to get you into the Zoom meeting, and then I'll send the file in chat and you can download it from there. But let me, there we go. And I'm also going to send it right now just for anyone following along in the Zoom.
So you're saying go to Discord for that?
You can just type in the link to your web browser, but Here.
I just have it.
So just extract that file to a place on like wherever you want, on the desktop.
This one here?
Yeah,
Okay.
and that's the one we do first.
Huh? I'll just put in documents we do.
Yeah, that's fine.
You open it.
So you don't want to, you don't open it yet?
Yeah, no, we're not running that file.
Okay.
We're loading it into our tool, so that's two different things.
I think it's.
Yeah, that's
trying to
what
open
it
it.
is.
Yeah.
Yeah, I had the same thing. I was trying to protect you.
Stop it for right now.
Yeah, it was the same thing for me.
Is it not done?
Wasn't opening in dnSpy.
Yeah, no, I have a bypass it. Still tell me it might be, not bad.
Yeah. We're good though, we're good.
Oh.
We're nothing crazy here.
Yeah, no, if anyone's actually like concerned of what's in the thing, I can show this.
Oh, no, that's fine.
Yeah, and it's only 28 lines of code.
That's good.
Yeah.
Because what we're doing is, we're actually gonna figure out what it does. Yeah, but you know, the password,
No, I take it.
that's on. That's on.
Jim?
Yeah.
That's
All
right.
right, I'll get one.
You guys taking it, trust their words.
Why is everyone running it?
I know.
I want one thing, and they do the other.
You just want to click it and run it, you know, just like have it.
It's reverse psychology. I want you guys to run it. No.
You tell it, it's like putting the cookies in, it's like, don't
Like
eat it.
not in the firewall.
Yeah.
You know, put it, you know, have you ever seen that with the kids?
Yeah.
The little test it.
I'll give it like another 3 minutes for you to figure it out and then we'll continue. But,
Are you in the Zoom?
huh?
Are you in the Zoom?
Yeah, no, I'm,
It's on there?
No.
Oh, okay, because I didn't see the camera.
no.
I'm gonna go on property use of the file.
Oh, okay.
That's what I was thinking.
Oh, you get it downloaded?
Yeah, just do this.
Anytime.
Yeah, quarantine's automatic.
Yeah, I know, Windows 200 is like the best.
You could also use your.
Thankfully, like the antivirus I have isn't like literally stupid. Like, I don't know how some of these companies can actually charge people money for like their antivirus because it's so bad.
Yeah.
But I mean, I guess the best policy is being overtly just against you downloading anything.
Yeah, it's true.
You good? All right. All right, so we're gonna load the file into our tool, so I'll show you how to do that. So everyone should have dnSpy already open if you're following along. Now, like I said, we're gonna use our file tooltip here, and we're gonna press open in our context menu, and you're gonna want to navigate to wherever you have the executable file that we just downloaded on your desktop or wherever you put it. And you're just gonna press on it, don't run it. And just press open, and you should see it pop up in the Assembly Explorer with all that information up there. We'll get to that in a second. Don't be overwhelmed because it's not that complicated. We're just gonna skim over it because in reality, I barely ever have to look at this part here. Just give me a thumbs up when you're all good. Okay, so what we call this stuff right here, this is metadata. Now, metadata is stuff that's attached to like literally every file on the internet. It's just information about the file. Sometimes it's where it came from, sometimes it's other stuff. And in this case, we get some information here, like we know our assembly version, which is the file. The version of the file is 1.0.0.0. It's just information about our file that we're dealing with here. It's important to know what this is because sometimes, and very rarely, if you're ever dealing with an application, whatever tools may have been ran on it could tag the file with some information. So this is specifically the case when you're running tools that modify the file, because companies like to put their like watermarks on a file, and this is kind of a way of them doing it. So they'll have like, oh, modified by X program or something like that. And that kind of tells you what's been done to it. So that's important to know. But other than that, we really use almost none of this information here. Maybe the last line of this thing is important, which is target framework. That just tells us which .NET framework it was coded in, but nothing else is really important here. That's pretty much it for metadata. Let's see. We also have access to our code structure here. So if we want to view the code structure, we can just open up this toggle list and we get our application here. Now, I'm going to run through some of the stuff here. These brackets here you see are namespaces. Now, if you've been doing programming and you've looked at like the code you've written or have like programs that have been auto-generated by Visual Studio, you'll notice that they usually begin with like namespace, specifically for CS111. It'll have like namespace, whatever you named your program at the top. That's what this is. So I'm actually going to bring up, actually, no, it's fine. So these are just namespaces, and for each namespace in a program, it'll show up here, and then it'll show you like what's in the namespace. This one, not really important. This has nothing in it. So we see there's a class called module. There's nothing in this. And rarely there ever is, unless you're dealing with something that's been highly modified to be like really compressed. Otherwise, it's completely empty usually, but it's still important to check because as a reverse engineer, you're exploring. It's like exploring a new program and you want to find everything inside that program. You have the resources. In this case, there's nothing in here for us, and we're not going to cover this today, but in the future, we'll probably cover it. There can be stuff stored like images in resources. That's pretty much it for what goes in resources. We have our references. I don't think in CS111 this was covered, but you can import stuff as a reference. So we're not going to cover that today, but we'll also cover that when we cover resources in the future. If we click on this, we get a bit of information here. We know that our program is a 32-bit program, but it can be run on any CPU. So that's something to note. It's cross-platform or cross architecture, if you will. So it can run on a 64-bit, it can run on a 32-bit, but it's 32-bit preferred. We also know the .NET framework It knows that from the metadata, so it's not really that important. We also know where the program starts. Now, this is probably one of the most important pieces to know. This is probably one of the most important pieces to know when it comes to reverse engineering. You want to know where the program starts, because once you know where the program starts, you can individually step through the application, see what it does. So in this case, we know our program starts in program.main. So if we actually open this up, we'll see that we have two classes, app and program. Well, we know that it's in the namespace ccc_re_workshop_1_app. So we open that and there's program. Now, if we open up this part, we see that we have a main function. That is our entry point to this program. That is the first ever part of the program that will run, and it will always stay that way. So if we actually click on this, we actually get a view of what that function is. Now, this is always pretty much the case for any window program or a UI program. It'll have this boilerplate code in here. This is basically just saying, okay, we're going to open this user interface and then let that code run. So we're not going to worry about this part because that's information that's not really relevant to us. So if we open up this app class, we actually see that we have some important information here. We know that app is a form. So this is our user interface. This is the part of the program that the user is actually interacting with. So we're actually going to explore this a bit and see what we can find in the program. So if we actually look around, we see that we have a few functions. There's a function called decrypt string, and it takes in a string argument. And we have a function called encrypt string, and it takes in another string argument. Then we have a button submit _click function. Now, this function, if we actually look at what happens when this function runs, or well, where this function is used, it looks like it's assigned to the button submit click event. So we know that whenever this button is clicked, this function will run right here. So let's take a look at this function. We see that it's assigning a Boolean called a flag, and it's going to be assigned to whether or not encrypt string of text password.text is equal to this string right here. So given that logic, if the encrypt string of any amount of text is equal to this is true, then we know that the password is going to be true. We know that we've successfully gotten our password correctly. We also have a this.decrypt string on the password right here. So we know that this is the encrypted password. And we know that if the decrypted version of that password is our text box input, we know that that's going to be the correct password. So let's actually take a look at how the encrypt and decrypt functions work. So it looks like we're having a text variable, which is a string. It's empty at the start. We iterate over every single character in the string that is passed to it. Now, it looks like when we do that, we assign the new string with the character, except we shift the character backwards by 1. So that means that if we call decrypt string with a capital B, what would be a previous character by 1? What would that be shifted backwards by 1? That would be a capital A. So we know that's how decryption works, and there's nothing else really going on for the decryption. So this is a really simple encryption and decryption process for a string, just to hide information to whoever doesn't really understand what's going on here. So we know that the password is this, right? So we know that the password is DJ. Let me erase this. I'm only going to make us manually do the first part of the password, but this will give you an idea of like how you could statically analyze this portion of the app. So if we look at this here, we know that the decryption is shifting it backwards by one character. So the capital D shifted back by one character is going to be the capital C. And then capital J is going to be shifted back by one character, which is a capital I. U shifted back one is a T. S shifted back by one is a capital R. V shifted back by one is a capital U. And T shifted back by one is a capital S. So that is the first part of the password. So just by looking at what's happening in the program, we can figure out exactly what needs to be input into the program for certain conditions to occur, to get certain parts of the program to run. So if we actually were to manually do this for the entire password, we would see that the entire password is actually citrus, cyber security, club 1. That would be the password to the program if we were to manually do the entire shifting back by one, the entire process by ourselves. Now there's ways to speed this up, and one of them would be using an online compiler. So if we were just to like use an online compiler, I could just, oh wow, I'm gonna take this code right here and I'm just gonna copy and paste it into here. And just by doing that, I now have this function in here and I can actually use this function. So I could just call this function right here and it would tell me the exact password. And if I run that, oh. Ooh, my bad. I think that's it. No, okay. Okay, it's not wanting to work, but if you were to run this in like Visual Studio or something like that, it would basically just give you the output properly and it would show you that the password is Citrus Cybersecurity Club 1. But I think the reason why it didn't work is because I wasn't doing this. Cannot convert type string to car. Yeah. So that would be the output of the password. And I'm not saying to run this, but I'm going to actually show you. If we actually run the program, we see that it pops up with a text box and a button. And if we input this password, Citrus Cybersecurity Club 1, we get correct password. And if it wasn't the correct password, if I had hello, the output incorrect password. So that's just a basic introduction to like how we can figure out how a program exactly works and how we can get certain things to happen inside a program. Yeah. So now we need to talk about some more important stuff when it comes to reverse engineering. So when it comes to reverse engineering, we actually now have an introduction to some of probably one of the most powerful portions of cybersecurity out there, which is the ability to understand how things work under the hood of programs. It's important to know that you have to use this ability responsibly. And as we cover more advanced stuff in the future, when it comes to reverse engineering, you're going to get better and better at it. And through that, you also can pose like a great risk when it comes to doing things that may or may not be illegal. So it's important to understand that you shouldn't be breaking any laws when you're using reverse engineering. If you are, then you're not doing something right. Your morals are completely out of the window, because this should be used responsibly and not with any ill intention. So you have to keep these things in mind when we get better and better at this specific skill when it comes to reverse engineering. Next time, for the next reverse engineering workshop, we're going to cover how to dynamically analyze programs. So we covered static analysis today, but next time we're going to be covering dynamic analysis, which is running the program and actually stepping through and seeing how it works. And we're also going to be discussing more ethics and the applications of this practice. And we're also going to learn how to keep ourselves safe. So as I mentioned earlier, when we talked about dynamic analysis, we're going to do that in a controlled environment. So for next time, it's going to be useful to have a virtual machine, because that's what we're going to be using to keep ourselves safe when we dynamically analyze these programs. I know you two have Parallels on your computer, which is perfectly fine. That's a virtual machine, so you won't have to do anything. But yeah, that is it. Thank you guys for participating, coming to this workshop. Do you want me to just like stop the shares?